In this video, we're going to try and tackle the Doppler effect for sound, but also consider that the same phenomena occurs with light and any wave. So I want to take us back to a problem that you did in P-Set 1. There was this boat in the water, and there were some waves that were moving towards the boat. You knew the speed of the wave, and you knew how far the crests were apart from each other. So that was the wavelength, 10 meters, and you could come up with some relationship to relate these quantities to the frequency at which the boat was getting hit by waves if these people threw the anchor over. We've got some anchor, and the boat is still. So let's do that. Velocity is wavelength times frequency. I know my velocity, I know my wavelength, so the frequency is just v over lambda, so 4 over 10, and that's measured in hertz. So 0.4 hits, or wave hits, per second. Waves per second. Okay, now the second part of the problem was a situation where these guys, they took their anchor back up, and now they're moving towards the wave at 1 meter per second. How often is the boat getting hit by waves? Well, now this velocity is different. And velocity is relative, so we can choose any reference frame. Let's choose the reference frame inside the boat. If we're inside the boat and measuring the speed of the wave, it looks faster. It doesn't look like 4 meters per second. In fact, it looks like the combination of these velocities. So the v prime, this new measured velocity of the wave, is 5 meters per second. Moving that way towards the boat, the wavelength is still the same. So frequency is 5 over 10 hertz. And that makes sense that the boat is getting hit more often by waves every second if you're traveling into the wave. And if instead you turned your boat around and started heading this way at 1 meter per second, well, the relative velocity of the wave would be, well, it would look like it was moving slower than 4 meters per second. It would look like it's going, and I'll call this v double prime, 3 meters per second. So if you're traveling that way, the wave itself looks like it's moving 3 meters per second towards you, meaning that the frequency for the same given wavelength would be 3 over 10 hertz. And that makes sense physically, that you would be hit with a wave less frequently if you're heading away from the wave. So let's try and make sense of this phenomenon with sound. And to do this, I'll bring you on over and ask you to consider a moment when you have heard of maybe a fire truck pass you by. When you're standing on the sidewalk, you see the fire truck and it's rearing towards you. Perhaps you've heard the Doppler effect by the increased pitch as it approaches. And then when it leaves you going the other way, you hear a drop in pitch, and that's because of the Doppler effect. As this fire truck is getting closer and closer to you, the relative velocity of the wave that you are hearing is a lot greater. So the frequency would be a greater value. And when it's receding from you, going in that direction, the waves are then, that are heading towards you in this direction, well, they're further spread out, and you hear, you're hit by this wave less frequently. So there's a drop in pitch because frequency is related to a pitch of any given sound. We could also apply this to light. So if we're here on Earth and we check out this star and it's beaming at us, and we could consider light to be a wave in this context, well, as light is heading towards us, if the star is moving away, then we would see the Doppler effect like this. And let me draw this a little bit better. Here's my waves. But the star is receding from us, so the distance here is getting larger and larger, meaning we're not hit by these waves as frequently. what does this look like when we actually observe it? Well, because this wavelength is getting larger, there's a redshift. So when we observe these stars over time, it looks like they're getting redder. And so we make the conclusion, if this star is heading away from us, and we look over here and we say we see the same exact phenomena, then that star must be heading away from us. Well, our universe must be expanding. I'll leave you with that. Goodbye.